Howdy. A little quake watch and an Easter egg. There are some rather interesting quakes. This has been, I think, a 4.5 in the... what is it? When they announced it. Notification. Now it's a 3.8. And this might be rather close to the Silver Pit crater, which might be here. This might be the Silver Pit crater, or it's not, but it's somewhere here. I made videos about that. You can find it on the internet, the Silver Pit crater. 3.59 hours ago, 8 kilometers in depth. Other sources, EMSC 3.5 at 102 kilometers in depth. So that's a rather big difference here, which is very interesting. How can they not agree on that? So now to the Easter egg. We have to go eastwards and northwards. We are at the border between Russia and Finland. And here we had a quake some hours ago. There was a second one, which was a little bit longer ago. That's why it's not visible anymore. 0 kilometers in depth as always, because they never tell us the depth. I want to point out these. These are very often found in peatlands, wetlands, or whatsoever. These structures. And I find them really, really interesting. And if you have time, you'll find them all over the place. I think the main reason why they aren't as abundant as they are nowadays is that many peatlands or areas which contain peat, they got drained and they destroyed partially the whole environment. I find them very intriguing, and I think it has to do something with electricity. This is from the same area. A picture I made yesterday, Google Earth, Finnish-Russia border. And as you can see, this one is magnified here in order to make it better visible. And here, on the lower part, we have a lightning strike. A picture made by myself. Yeah, it has similarities. At least I would say it has similarities. It's not the same, of course, because not all, but many ingredients are a little bit different. But it has similarities. Yeah, and I wrote a paper about peat. It's not published yet anywhere. And I still wait for anyone to comment on that, which also didn't happen yet. Except, no, it's not true. Actually, one person, which I don't know who it was, told me it's nothing, it's bogus. It's total crap, because everything is known already. And he or she also suggested that I probably should start to study geology. Yeah, it could be difficult here. But anyway, it's simply called peat in the fluctuating geoelectric environment and its contribution to the end of the last ice age. Abstract, which is rather short. That's a rather short paper. I tried to keep it short. Peat is something most of us are familiar with, at least to some degree. It is found all over the globe and usually related to water. The origins and creation of it are not well understood, and it is classified as a geomorphological phenomenon. In other words, they don't really know how it got created. The end of the last ice age seemed to have happened rather quickly in terms of melting. I think that peat might have played a crucial role in some of the melting processes due to its electromagnetic properties. Introduction. There is no meaning, only purpose. Nothing happens without a cause, and every cause has an effect. Earth provides an ever-changing environment for life in a cyclical manner. It and all the other planets, with all their moons, are contained within the Sun's magnetosphere. Or is it heliosphere? I wrote now magnetosphere. It's in a way the same thing, but because it's relating to the Sun, it might have a different name. Principle is basically the same. The most outer shell layer. The Sun is nowadays not only geographically the center of our solar system, but also energy-wise. This implies that it might have been different in the past. All the planets are constantly connected to the Sun by interplanetary Birkeland currents. The Sun, and therefore all the planets of our solar system, is constantly connected to the center of our galaxy with intergalactic Birkeland currents. Birkeland currents are strings of electricity which have many recognizable patterns, of which the most important to understand are magnetics. Every electric current has a magnetic field, sphere, because it's after all more like a sphere than, we have the field lines, but anyway. And every magnet has electric currents flowing around and through it, the magnetic flux. Every living being is electromagnetic by nature, and every process can be explained with electromagnetism. It is scalable from the atomic realm up to cosmic size. Peat or torf is known to most people around the world. It can be found almost on every continent on Earth. Peatlands, which also includes marshes, bogs, muskox, and moors, are easily recognizable since they have a distinct look, as well from ground level as from above. They often have a brownish or reddish color and water bodies. It has been used by people for centuries in different ways. Some preserved their food in it, others used it for leather processing, and people were even buried in it. I won't make now a whole read through to that. Let's go just a little bit down. Maybe still a bit more. Now let's just read here a little bit. Creation and accretion of peat from a new perspective. Let's go back in time, let's say 70,000 years or so. Some parts of Earth were covered by ice and snow, but also vast forests and grasslands covered the surface of the Earth. Huge herds of animals fed on the abundant food sources, and also the forests were full with all kinds of animals. Some settlements of people were found rather sparsely contributed over the landscape. This assumption could be totally wrong. The amount of people, the size and amount of settlements could have been much bigger than anyone could ever imagine. It is mainly based on archaeological findings within the paradigm of consensus theory, but it is not a crucial part of this paper to discuss whether there were many and sophisticated cultures present or not. We are treating all animals, people, and plants equally as biomass, because all biomass on Earth is based on carbon. In a study of the inorganic chemistry of peat in the Okavango Delta system in Botswana, is stated that the main source of inorganic matter, quote, Allochthonous kaolinite, 40% and quartz 20%, and both allochthonous and autochthonous phytolithic silica, point. Several inorganic components, Fa, K, P, Na, Ca, and magnesium, which make up the remaining 10%, are associated with the organic fraction. It is important to understand what the words allochthonous and autochthonous mean in order to point out something significant. Autochthonous means that the minerals were found at the same place where they were formed. They got created in situ. Allochthonous, on the other hand, means that they were formed somewhere else. In other words, they don't know where they came from. The term for something in between is parachthonous. Despite this being not relevant, I mention it here for the sake of completeness, and it's a funny word after all. Phytolithic silica is still an unsolved problem in botany. Plants somehow create cell-sized or even several cells combined size silica deposits, which also have the form of a cell. The reason for why or how exactly it happens remains unclear. These parts of plants have stored CO2 and other chemical compounds stored within this piece of silica, which does not decay for thousands of years. As earlier mentioned, we have 30% silica and also 20% quartz in peat, at least in this particular case. Quartz and silica are the same material, so why are they mentioned this way? The difference between the two lies in the arrangement of the atoms. Silica is amorphous and quartz crystalline. The easiest way to explain the difference between the two is the production of glass. Quartz-rich sand or quarried quartz, rock quartz, gets heated up to about 1700 degrees, the melting point of quartz, by which the crystalline structure disappears and gets clear. Otherwise, you wouldn't be able to watch out of the window due to the refraction of the crystalline structure of quartz. Of course, the process of glass making is much more complex. Many other things take place, like taking out impurities and adding chemicals in order to make the melting point lower. The final properties of glass can also be influenced by the cooling process, either slow or fast. Some glass is also chemically treated in order to get a very hard surface. This process is called ion exchange process, which exchanges sodium ions with potassium ions in a salty solution. Most glass produced is a mixture of three main ingredients and therefore called soda-lime glass or water glass. Commonly the mixture is 75% silica. Rock quartz is used more often than sand. 10% lime, calcium oxide, and 15% soda. The fact that peat contains amorphous silica indicates that it must have experienced some kind of extreme heating, at least some 700 degrees. When searching for sources of heat, common theory refers usually to volcanic activity or heat, which occurs deep underground in order to provide an explanation. Sometimes also asteroid impacts are also used as a source of heat, which could be possible. We know that Earth is a capacitor in space, so we have to take fluctuations in Earth's electric circuitry into account and remember the scalability of them. The amount of energy the universe could provide is immense and hard to imagine. All the different layers of Earth contain energy. The atmosphere, with its many layers, is no exception. Everybody has experienced lightning. It is an atmospheric discharge event, except it is positive lightning rising up from the ground, which can be seen as a ground discharging event. Exception. An exception is, maybe this has to be changed a bit. Anyway, a lightning bolt has an approximate heat of 50,000 degrees Fahrenheit or 27,760 degrees Celsius. It would evaporate silica. It changes its state from liquid to gas at 2,900 degrees Celsius. Until 1,414 degrees Celsius, it is solid. Polar lights, or aurora borealis australis, produce up to 1,400 Kelvin, 1,126.85 Celsius temperatures. It might also be much higher, like Steve is about 3,000. Maybe I have to take it in here as well. Earth's magnetic field is weakening. The poles are on the move, and we are experiencing already many kinds of changes in the weather, seismicity, and volcanic activity, not only on Earth, but also on almost every planet in our solar system, the Sun included. Yeah, it's a star. Saturn is a star too. With this said, it is clear that the atmosphere can produce heat sufficient enough to melt silica. With more and more recurring rare events, such as the rare pink aurora, we only can imagine what happens when the aurora actually touches the ground. Some of the indigenous people of Australia associate aurora with fire, death, and destruction. Their ancestors have survived such an event. One of the best-known ancient stories from the Aborigines is the story of the rainbow serpent, which is very closely related to water. It is said that it connects from water body to water body, and it is the reason why some water holes never dry out, even in extreme drought conditions. In other words, a plasma discharge, either ground to cloud, cloud to ground, positive and negative lightning, or a ground to ground arc discharge, from water source to water source. Some remnants of these events still visible today are water holes, kimberlite pipes, and mountains. This might be the origin of the saying, "At the end of the rainbow is a treasure." Kimberlite pipes are places where diamonds are found. These kinds of events must have produced unimaginably powerful shock waves. I propose that peat got formed by the induced currents of shock waves created by plasma discharges. The shock wave pulverized and heated up all biological creatures on the surface of Earth in the vicinity of the shock. In an instant, some of the material evaporated, some of it burned, and a fair part of it got vitrified. These events happened rather regionally, but may have occurred several times with different magnitudes. We have to remember that these events didn't take place on a sunny day. In other words, the weather was bad, very bad. Water has been everywhere, hence clouds, rain, different kinds of water bodies. The process got cooled by the water present in the atmosphere, and like in glass production, where different styles of cooling processes are used, the melted silica went through many stages of heat processing with all kinds of results. The presence of water in the atmosphere might have fluctuated greatly from place to place. Biological life forms contain water all by themselves, which means water was always present, but maybe not in an amount which would have been sufficient for having a cooling effect. Material could have undergone several electromagnetic transmutations, and due to the fluctuability of the events themselves, some material could have undergone some changes in its chemical composition, whilst other materials didn't change at all due to their chemical composition and therefore electric circuitry, i.e. geometry and charge potential plutonic solids. Things like heat, strength of the induced currents, polarity of the event, hence the magnitude and nature of the event, has had very great influence on the outcome. Peat got instantaneously pulverized and then carried away by the winds. Maybe this should be the biological forms. But anyway, maybe peat also. Due to its biological origin, it is lighter than stone dust, so it stayed aloft much longer, maybe for months or even years, and settled as the last layer. That's why it is often found as a top layer. Peat is heavier than water, so it will accumulate in places with water where wind doesn't carry it away, such as the bottom of the seas. This also means that peat found in certain places might have had its origin somewhere else and could be seen as a deposit. The relative high content of metals in peat is also a very important factor to notice as a factor of electromagnetic separation according to their magnetic properties in different temperatures. The accumulation of peat in certain areas is quite likely linked to surface conductivity, magnetic features, and other things which could have influenced the accumulation of the peat cloud. After its first accumulation on the ground, it experienced a secondary accumulation process. If it dried up, wind carried it again to other places. As we speak now of winds after the event, we can use the term in a normal sense. The ionization of the atmosphere has decreased significantly, and electromagnetic properties of dust don't have the influence as they had in a strongly ionized environment. It might also be possible that some parts of dry peats gets carried away by winds because they are smaller and lighter than others. If peat got accumulated in places with water bodies, it started to accumulate in ponds and lakes. Further accumulation into standing water bodies happened and still happens through drainage processes from precipitation. But anyway, this was a small part of what I wrote about peat. This is not finished yet. I have some pictures here. I mean, real pictures. And here's just a reference list. It starts at 1, of course, and it ends at 133. So it's a rather long reference list. And one of those references I use here is the hydrogen chloride cannon. Let's just check it out. That's professional. Hydrogen chloride cannon. Check this out.
In this demonstration, I want to show you a chemical reaction that we will look at in more detail to see how thermodynamics helps us explain in quantitative detail what we observe qualitatively. In this apparatus is a tube that has been filled with a mixture of hydrogen gas, H2, and chlorine gas, Cl2. The tube is further encased in a clear plastic sleeve for reasons that will become clear shortly. These two gases can react with one another to make a new gas, hydrogen chloride. Dissolving hydrogen chloride in water is how hydrochloric acid is made. Just as was true for the thermite reaction, demonstrated in this course's introductory video, reaction of H2 and Cl2 to make HCl is favorable, but it requires an initial kick to get the reaction started. And that kick is the energy required to break the bond between two chlorine atoms in Cl2, which amount of energy is 242 kilojoules per mole. I'm holding here 3 different laser pointers. One lasers red light, one green light, and one blue light. As we'll see in some exercises in an early lecture, the energy of a photon, which is the fundamental unit of light, is determined by its wavelength. The red, green, and blue laser pointers emit wavelengths of 650, 532, and 405 nanometers, respectively. Let's see which, if any, of these wavelengths seems sufficient to break the chlorine-chlorine bond. Here's red shining into the gas mixture. Not much happening. Now, green. Nothing. Now let's try blue. Now let's try blue.
Yeah, he has a very good timing. I mean, my little friend here. So now let's try it once again.
Now let's try blue.
Now we got the pop. So now, Earth's magnetic field is weakening. We have different kinds of rays which are coming in due to that. And There are those odd craters in peatlands, Siberia. Nobody knows how they got created. And here is just a random example I just found. BBC, the mystery of Siberia's exploding craters. And now I've been thinking, is it anywhere possible that if there would be some electromagnetic fluctuations, like I've been talking about surface conductivity, anomaly, interfaces of polarities, if there would be a possibility that a beam of light would, through those electromagnetic properties, if it would point at a special point in this landscape, could it trigger such an explosion just by the color of light, by the wavelength which is hitting the surface? Which also relates to peat. But I stop here now. You can put, yeah, it would be nice to somehow, if anyone could make a comment like, it's total crap what you're talking about or whatsoever, we can talk about it. I like, as you have seen, there is more text and more stuff in the whole paper. I just showed you a little part of it. But anyway, I think it's interesting that I haven't really got any response to that yet, really. One, which wasn't, yeah. It's not surprising because it seems the individual which made the review might still be in this kind of gravitational paradigm. I don't know. But anyway, I just wanted to share this with you. Thanks. Bye.